So the quadratic formula. Well, let's just look at a parabola. Any parabola can be put in the form y equals ax squared plus bx plus c. This is our standard parabola. Few things you know about a parabola. If a is positive, it opens up. If a is negative, it opens down. Now, some parabolas cross the x-axis, maybe twice, as many as 2 times. Some parabolas only cross the x-axis once. Some parabolas do not cross the x-axis at all. Everyone good with this? I'd like to talk about all 3 of those situations. First situation, if a parabola crosses the x-axis, I know some very specific information. I know some exact values about that. Because when I look at a point, I'm given x values and y values. The x value tells me how far I am away from the y-axis. The y values are up and down, so they tell me how far I am away from the x-axis. So if I look at these 2 points here, this point and this point, for any parabola that crosses the x-axis, twice, I know that both points will have a y value of exactly 0. So I don't know what this first x value, so I will call it the first x value. But the y value I know for a fact is, and on the other point, I don't know what this x value is, the second one, so I will call it the second x value. That's all the subscript means. It doesn't mean a specific location or anything like that, just the second x value that I'm observing. But I do know its exact y value. And that exact y value is 0. Now, if you have a formula such as y equals ax squared plus bx plus c, this is a formula that lets me go back and forth between x values and y values. Yes? And I know the y value is 0. So if the y value is 0 in this case, then the parabola can be written in this format. And I should be able to come up with a valid solution for it in this format. Everyone okay with that? I have developed, well, not me personally, but mathematics has developed a technique that allows me to directly find those 2 x values. We call that the quadratic formula, which was developed by completing the square technique. So immediately I can find x1 and x2 by using negative b plus or minus the square root of b squared minus 4ac over 2a. Notice this will produce 2 x values. One where I take the positive of the square root, one where I take the negative of the square root. So far so good? I'm going to do an example of a situation like this, and we're going to use the quadratic formula to find those x values. Then we're going to put it in reduced radical form. Yes, sir?
So you would only use that formula when you're trying to find x?
Personally, I would only use this formula in a parabola if I knew that it had 2 x-intercepts, personally. However, I'm going to show what happens when we use this formula, not only when there are 2, what happens when we use this formula when there's 1, and what happens when I try to find something that does not exist. Now, and then after that, it'll make sense why I would only use this formula if there was 2 x-intercepts. So, let's take a look at how we would normally go about this technique. Let's look at y equals x squared plus 4x minus 6. There are a few ways I can determine whether it crosses or not. This one's kind of easy to determine whether it crosses or not because my y-intercept is at 0, -6, and this parabola is opening. So if I'm below the x-axis somewhere, I already know somewhere it's below the x-axis and it's opening up, it's going to cross twice. Everyone all right with that? However, generally when I graph a parabola and I identify all of its key points, I like to start with identifying the vertex. So I'm going to start by identifying the vertex. You should know that the vertex has an x value of h equals negative b over 2a and a y value that we call k, which we get when we plug in the negative 2 into the formula. So I'm just going to take and I'm going to plug in my negative 2 and square it plus 4 times negative 2 minus 6. I'm just plugging it directly into the formula as it looks in my calculator, hitting enter, and the k value or the y value of the vertex is negative 10. So I've got an x value, I've got a y value. I'm going to make a rough graph. The parabola opens up. Let's put it in green. The parabola opens up. I have a vertex located at negative 2, negative 10. Now, I'd like to talk about what negative 2 means. Negative 2, the x value, tells me how far I am from the y-axis. This vertex is 2 units to the left of the y-axis, so the y-axis must be over here to the right of it. The negative 10 on the y value says that my y location is 10 units below the x-axis, so my x-axis must be somewhere way up here, 10 units above. So here are my y-axis, here are my x-axis. I now also have located this point here, my y-intercept. So the only thing I'm missing at this point is this one point and this one point. And of course the parabola goes beyond it. But those 2 points we call our x-intercepts. I know the y value for both of those points is 0. So I can take that formula and I'm going to plug in 0 for the y value. When I plug in the 0 for the y value, I notice that this is the form that allows me to use the quadratic formula. So I'm going to utilize the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4a C over 2A. Now, I'm going to name part of this radical. When we use the quadratic formula, what I want you to notice is I've got a number under the radical. I need to be able to find that value for me to know that there are two answers, which means that value must be there, must be a real number. So the value under the radical, this number here, just the number under the radical, is referred to as the discriminant. If I can take the square root of the discriminant and come up with a real number, then I will have two x values. One where I have the positive of that number, the other where I have the negative of the number, and I have two x-intercepts. So, when we take a look at that, let's go ahead and simplify this radical. What I am going to do, plus or minus square root of something over 2. All I'm going to do is throw that in my calculator, and I've got what? 4 squared minus 4 times 1 times negative 6. Make sure you use proper use of parentheses when you do a substitution, giving me a 40. That is my discriminant. My discriminant is a positive number. That's important because you can take the square root of a positive number. Now, I'm not going to put it in decimal approximation. I'm going to go ahead and put this in reduced, radical, reduced, fraction format. Everyone ready for that? So, 40. I look at 40 and I ask myself, what is the largest perfect square factor of 40? And the answer is a 4. A 4 is the largest perfect square factor. So, I'm going to take this, move it over here to the side, doesn't matter. X is negative 4 plus or minus the square root of 4 times the square root of 10. So I skipped one little step, just combined two steps in one, because 4 times 10 is 40, and I split my radical into two radicals. I did that because I can take the square root of that 40. I'm just going to move my work up here a little bit so it's easier to see. So now what I have, negative 4 plus or minus square root of 4 is 2 over the square root of 10, times square root of 10 over 2. Now I'm going to look at my numerator and I'm going to ask myself, what is the largest common factor, or the greatest common factor in the numerator? That greatest common factor is a 2. I will factor it out and rewrite this in factored format. No, I have to be a greatest common factor, must be common to both.
Of those numbers?
Yes.
Even the 10?
No, because the 10 is inside the radical. It's radically different than a 10. So, I look at my 4 and my 2, the lead coefficients, and I'm only looking for what's common to those two numbers. Factor that out, then we reduce 1 to 1. I have a 2 on top, a 2 on bottom. They reduce 1 to 1. Those are two separate x values. They are in its exact format as we can write those. However, many times we like to look at the decimal approximations for placing them on the graph. But even so, I would still write them in the reduced radical, reduced fraction format because it is the most accurate way to display them. You will be required on the final exam to have your answer in reduced radical, reduced fraction format. So, just so I know where those two numbers are, and let's talk about those two numbers. The first one is -2 minus the square root of 10. The other one is -2 plus the square root of 10. I'll go ahead and plug those in my calculator to get a decimal approximation. -2 minus the square root of 10 is, so this is my approximation, -5.16, and -2 plus the square root of 10 is 1.16 approximately, which should match basically what I have on the graph already. So the value should look reasonably close to what I made on my rough graph. So I now have the two x values I was looking for by using the quadratic formula. And I'm going to label the first one, the point, that's the one to the left because it's negative. The point is the x value is -2, oops, it's not there, minus the square root of 10, the y value is 0. This point, the x value, let me write it up here, is -2 plus the square root of 10. The y value is, and my graph is fully labeled with the vertex and all intercepts. So far, so good? Now, that was the first one. The second one, if it only comes down and touches the x-axis at one location, that one location we call the vertex. And I know where the vertex is located. For this one, the vertex, I know how to find. The x value of the vertex is called -b over 2a. The y value is because my vertex is called HK. H is found by taking -b and dividing it by 2a. I already know what the y value is. If the y value is on the x-axis, the y value must be 0. If we use the quadratic formula, it should work because y can equal 0, yes? So how do I get one answer when I have my discriminant producing a plus and minus number? It must be a real number, but there's only one real number whose square root positive is exactly the same as its square root negative, and that is the number 0. And notice what happens if the square root of 0 is used in this formula. What do I end up with for my x value? If this is 0, the square root of 0 is 0, then x equals -b over, which is the x value of the, only if the discriminant is 0. Everyone very clear on that? If the discriminant is 0, the vertex is the one and only x-intercept. So, I'm going to put some notes here. Condition 1, the discriminant, and I'm just going to write what the discriminant is, it's this number. Only occurs if this discriminant is a positive number. Because I can only take the square root of a positive number or 0. And if I take the square root of 0, if this is 0, then my quadratic formula will produce one and only one solution. So far, so good? So, in this case, I end up with, two real solutions. Over here, I end up with one real solution. So, I have taken care of when the discriminant is positive. I've taken care of when the discriminant is 0. The only thing left is negative. Let's take an example of trying to find something that does not exist. So, that is case number 3. There are no x-intercepts, which means if you set y equal to 0, this formula should not produce a real solution. How can it really produce something that we already know does not exist? So let's examine that. I'll go ahead and start off by finding the vertex. The h value of the vertex is negative b over 2a, which produces a negative 2. The y value of the vertex is f of negative 2. I'm just going to use my calculator. Negative 2 squared plus 4 times negative 2 plus 6, enter, and I get the y value is a 2. So now I'm going to notice that my parabola has a positive a value of 1, which means my parabola will open up. My vertex is at negative 2, 2. I'm going to talk about the negative 2 in the x value. The negative 2 in the x value tells me this point is 2 units to the left of the y-axis. So I'm going to write the y-axis on the right about 2 units. So far, so good? Now, my y value of 2 tells me that this point is 2 units above the x-axis. Because a positive y value is above the x-axis. So my x-axis must be 2 units below this. So I'm going to write my x-axis 2 units down. So this is an approximate graph. And notice I've also located my y-intercept by looking at the formula at the point 0, comma. This parabola does not have any x-intercepts. So what happens if I attempt to find something that does not really exist?
error.
Exactly. Something must go wrong. So, let's do it. We are going to look for, I'm going to set y equal to 0, which we know cannot happen. There's no y location on there goes down that far. And I'm going to attempt to solve this using the quadratic formula, where x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, I'm going to simplify. Negative 4 plus or minus something under that radical over 2. What is in that radical? Let's find out. I'm just going to use my calculator, and I'm going to write it in my calculator exactly as it looks. That is the number under the radical called the discriminant. That number is negative 8. Negative 8 does not really exist. It's not a real number. However, I can express it as a complex number. So this has no real solution because it doesn't really cross the x-axis. But I'm going to go ahead and write the solution as a complex number in reduced, radical, reduced fraction format. So, two things I'm going to separate out from the radical. I'm going to separate out that negative 1. I'm going to separate out the largest perfect square, which is a 4. And when I factor out a negative 1, I get 8. When I factor out a 4, I get a 2. So my answer is going to look like negative 4 plus or minus. I can take the square root of the 4, giving me a 2. The square root of negative 1 I can rewrite as, and I still have this number under the radical. The greatest common factor to a 4 and a 2 is
2.
And this fraction is reducible. I now have 2x values. Oops, don't need that. These are called the complex solutions. They have complex solution because the answer isn't real. It has an imaginary component because my parabola does not cross the y-axis. I'm sorry, the x-axis.